So what I'm going to try to do here is show you 4 different ways to multiply two binomials. And the first way is by strictly just using the distributive property. So what I'm going to do here is I'm going to distribute x to x minus 4 and the positive 3 to x minus 4. So let's see. So I have x times the quantity x minus 4 plus 3 times the quantity x minus 4. And from there what I'm going to do is further distribute. So I'm going to distribute the x to x minus 4. Then I'm going to distribute the 3 to x minus 4. So let's watch that happen. So we get x squared minus 4x plus 3x and then minus 12. And the next thing I'm going to do is look for like terms, and I find those. So combining those gives me minus x. So final thing there is x squared minus x minus 12. But that's not the only way to do this problem. So the next way that I'm going to do it, I mean, it's exactly the same problem, is I'm going to do it geometrically. So what I'll do is I'm going to make a rectangle and divide it up and put each part of each of the binomials along the edges. So I put x and a plus 3, and then I put an x and a minus 4. Now what I'm going to do is actually just multiply those out. So I'll end up with an x squared plus 3x, a minus 4x, and a minus 12. So what I'm doing is basically I'm kind of finding like an area model. I'm finding the area of each of those little rectangles, which gives me that. Now when you do this, if you allow for placeholders, so every power of x from the highest down to the lowest, you then look along the diagonals, and that's where your like terms are. So I have just an x squared term, then I have the 3x and the minus 4x, which combine to be minus x, and then the minus 12. So that's kind of a geometric, I guess, area model. Here's another way that I kind of learned to do it. It's a little different, and I don't really like it because it's not going to work really well for for larger terms. So if we have a trinomial which has 3 terms and so on, but I think that it kind of ends up looking like a weird smiling face. So here's what we do. So I do x times x, and then I'm going to do x times negative 4, which gives me negative 4x. Then I'm going to do 3 times negative 4 to get negative 12, and then 3 times x, and then I'm going to, again, have to combine some like terms, and you can see I get the same thing. I don't know if you can see it. I think that kind of looks like a guy who, I don't know, has some weird eyes maybe, and those inner parentheses are like his nose kind of, and his hair, whatever. Again, that's not my favorite way to do it, although that is the way that I do it in my head. And finally, we'll look at the exact same problem again, but we're going to do this one kind of actually the way you probably learned to multiply numbers if you ever learned how to multiply numbers. So what I'll do is I'm going to put the x plus 3 on the top, the x minus 4 on the bottom, and now I'm just going to multiply. So I'm going to take negative 4 and multiply it through. So negative 4 times 3 is negative 12, negative 4 times x is negative 4x. And now what's important is when I multiply everything by x here, I don't get a constant term. So that's like the 0 that you would put down there if you were doing multiplication. So I put a 0 in. X times 3 is 3x, and x times x is x squared. And now, again, I just add down as I would if I were doing a normal multiplication problem. And I get that. So it's 4 different ways of getting the exact same answer, but that's how you kind of distribute binomials, multiply some binomials together. So 4 techniques. I hope you like one of them. You should probably learn all of them, though, because they're all pretty good. Good luck.